Good morning, students. So in the previous classes, we discussed about what exactly power diodes and what are the different types of power diodes, what are the characteristics of power diodes. Okay, that is VI characteristics of power diode, as well as we discussed about the reverse recovery characteristics of the power diodes. Okay, what are power diodes, what is the reverse recovery time of each diodes, what are the different types of power diodes which we are using in a power electronic system. Okay, and construction of the power diode, how it is constructed. Okay, physical structure of power diode, how physically the power diodes are looking like. Okay, so all those things we discussed in the previous class. Okay, next in the same module, second bit of the first module I'm talking about here. So here the second module is all about the rectifiers. Okay, diode rectifiers. Okay, so before going to the actual what exactly rectifiers and what are the different types of rectifiers which we are going to study in this particular module, okay, let me start with what exactly the rectifiers is. Okay, before going to the definition of the rectifiers, we'll discuss what are the different types of rectifiers we will be having here. Okay, so here AC to DC conversion, the rectifier means it is an electronic circuit which converts the alternating current into direct current. Okay, AC to DC conversion. Okay, that is called as rectifier. The process of conversion of AC to DC is called as the rectification. Okay, the rectification is nothing but it's the process of conversion of AC signals to the DC signal is called as the rectification process. Okay, so here in this rectifier we have once again single phase half wave rectifiers and single phase full wave rectifiers. Okay, so we have a three phase rectifiers also, but it is not included in this particular syllabus. Just I am talking about what all the even half wave rectifiers are also not included. Just I am telling what are the different types of rectifier circuits which we are having in the rectification process. Okay, two types of mainly it is in case of single phase rectifiers. There are two types of single phase. So single phase half wave rectifiers, single phase full wave rectifier. It's a single phase half wave, single phase full wave rectifiers. So in single phase half wave, once again uncontrolled rectifier which is connected to R load. Okay, load side of the rectifier is R and RL load. So uncontrolled rectifier with R load and RL load, controlled rectifier with R and RL load, then freewheeling diode. Okay, these are the different types of half wave rectifiers. So half wave, as the name itself says, only half cycle of AC is converted into DC here. Okay, that is why it is called as half wave rectifier. So controlled rectifier and the uncontrolled rectifier. What is the difference between this controlled and uncontrolled rectifier? So the uncontrolled rectifier, the switches are used are diodes. Okay, in the uncontrolled rectifiers the diodes are used. In the controlled rectifiers the SCRs are used. So SCRs, operation of this SCRs can be controlled, whereas the operation of the diodes is cannot be controlled. Okay, it is uncontrolled rectifier and controlled rectifiers here. Okay, two types of rectifier circuits we are having. I told what exactly the difference between the controlled rectifier and uncontrolled rectifiers. So the controlled rectifier we are using the SCRs. Okay, whereas in uncontrolled rectifiers we are using the diodes. Okay, that is the difference between the controlled and uncontrolled. Freewheeling diode is also used in some of the rectifiers, so that is why it's also given as one of the form of rectifiers. So here uncontrolled diodes are used, controlled SCRs are used. Okay, the operation of the circuits can be controlled here in a controlled rectifier. Okay, whereas switching operation is not possible to control in case of the uncontrolled rectifier. This is single phase. Why? Because so if you're having a one AC signal, okay, if you're having one AC signal like this, so only first half cycle of AC is converted into DC here. Okay, second half cycle it will be 0. Next once again positive half cycle will be this one. Like this it will be coming. So that is why it is called as half wave rectifiers. So single phase full wave rectifier. So just look at this. This is your AC waveforms. In case of single phase full wave rectifiers, we are using two diodes. So one half cycle, first positive half cycle, one diode is conducting and it will convert the AC to DC. The negative half cycle, another diode will conduct and it will convert the AC to DC. Okay, that is the full wave rectifiers. So that is the difference between single phase half wave and single phase full wave rectifiers. Okay, so in case of single phase full wave rectifiers also we have uncontrolled rectifier and controlled rectifier, that is once again continuous conduction mode and discontinuous conduction mode. The operation of this may be divided into continuous conduction mode and the discontinuous conduction mode. Here also, based on the type of switch used here, they are classified as uncontrolled and controlled rectifiers. Uncontrolled diodes are used, okay, this is the diode symbol, okay. For controlled rectifier, SCRs are used, okay. What is the difference between, this is your diode, okay, SCR is we having a gate here, okay, anode, cathode and gate, okay, whereas controlled rectifiers we are using the diode, only anode and cathode it is there. So if the anode polarity is more than the cathode polarity, diode is acting, whereas in SCR if the anode polarity and cathode polarity are as per the specifications but the gate is absent, then your SCR will not be working, okay. So that is the difference between using diode and using SCR. So that is called as uncontrolled and controlled rectifiers. This is in continuous conduction mode and discontinuous conduction mode. These are the modes of operation of this SCR that we will discuss in detail when it comes to this one, right. This is the different types of rectifiers which we are having: single phase, full wave, half wave. In case of three phase also we are having a full wave, half wave type of the rectifiers that we will discuss whenever it comes. So in this second module we don't have a three phase rectifiers, okay. So three phase rectifiers we are having in the fourth module, I hope so. There we'll discuss in detail about that, okay. So next is rectifiers. So just introduction, there is no need of introduction, I already told it. So rectifier is the conversion, it's an electronic circuit which converts the alternating current to the direct current, okay, alternating current to direct current. So if you want to define it in some terms, in the form of a definitions, if you want to define, so converting AC, that is just written in a bracket, from mains or other alternating current source, okay, from mains, from the supply, that is generating stations, whatever getting, that is, or from the other alternating source, okay, to DC power by using the power diodes, okay, or by controlling the firing angles, by using the power diodes or by controlling the firing angles of the conductors in case of the controllable switches, okay. So that is the definitions: conversion of AC to DC using a power diodes or using the SCRs, okay. That is the definition of your rectifiers. What is the purpose of rectification? Why should we require the rectification process, okay. So there are few points I have given here, so to elaborate on the purpose of rectifiers, so first point is to produce an output that is purely DC, okay. So to get the pure DC form of output, so the rectifiers is required. So first point. Next, to produce the voltage and current waveforms that has a specified DC component, okay. So DC component, why DC component is required, why DC voltage is required? So the question may comes in your mind that why DC is required, okay. See, your mains comes from the KP-TCL, okay, mains comes from the KP-TCL is of AC, okay. All the equipments which are used in the houses are not of AC, okay. Some of the equipments are of DC, okay. Some of the electronic equipments requires DC supply. So in that case, what you do? The rectification is the only option. You have to go for the rectification. So that is why the rectifiers plays a role here, okay. So to convert the alternating currents which is coming from the KP-TCLs or the electricity boards to DC voltages which is required by the applications which we are using in the houses, so conversion of one form to other form is required. If you directly give AC to the DC components, DC equipments, your equipments will spoil. That is why the conversion of AC to DC is required. So once again, if the conversion is required, then rectifiers are required, okay. That is the purpose. So next is half-wave rectifiers, normally used in a low power applications, that is low applications. Half rectifiers means it is one type of half-wave rectifiers, only one cycle rectification is happening, so it is used in the low applications only. So in almost all the multiple higher applications, so high power rectifiers are used, okay. That's about the purpose and need of applications. Then the rectification, it is already told already. Rectification is a process once again of converting of alternating current, alternating voltage, okay, or current into a corresponding direct quantity, that is voltage or current. Quantity means we are using converting the voltage to DC to AC. Current, once again, it is along with that conversion of alternating current to direct current, okay. So that is the input to the rectifier is an AC, okay, whereas So the input of the rectifier is an AC, whereas its output will be unidirectional DC here. So rectifier, so it is a rectifier block if you're taking rectifier. So it is a conversion of alternating current to direct current. Okay, that is the rectifier here. So it is already told here, rectifier is an electronic device which is used for converting alternating quantity to direct quantities. Okay, the need of rectification, why the rectification is needed, I already some few points I given in the previous slides. Just some more points to be added to that one is a need for the rectification, why this rectification is needed. So every electronic circuits such as amplifiers needs a DC power source for its operation. If you take an amplifier itself, so electronic circuit that definitely needs a amplifiers needs a DC source for its operation. Definitely their DC conversion is required. So this DC has to be obtained from the AC mains only. So we don't have any DC supplies from the electricity boards. The electricity boards are providing us alternating current only. So definitely the need of conversion of AC to DC required for the different applications. That is why it is used. Next for talking about the, so for this AC supply has to be reduced, okay, and stepped down first using the step down transformer and then converted to DC by using the rectifiers. So from your supply means we are getting around 230, 440 volts, 11 kilovolts based on the which line we are talking. So from the generating stations to transmission, they are in terms of kilovolts they are transmitting. So once it comes to generator distribution side, then it is stepped down from 200 kilovolts or 11 kilovolts to 230 volts and something, then it is fed to your supply. So from 230 volts it is stepped down, then it is fed to the rectifier, there it will convert one form to other form, then it is passed through your applications. Okay, that is the need of your rectifiers. So next is half wave rectifiers. Half wave rectifiers, what it does, half wave rectifiers, as already told, this half wave rectifiers, we are not actually, this particular module will not deals with the half wave rectifiers, but the function of this half wave rectifiers, the operation of this half wave rectifiers, and also experimentally how this half wave rectifiers will be operating is already studied in the analog electronic circuit in the previous semester. Okay, that is why it is not yet included in this one half wave rectifier, just to brush it out. Okay, just to remind you some of the concepts related to half wave rectifiers. So I am just showing one of the half wave rectifier circuits along with a waveform, okay, just to make you to understand the full wave rectifier operation. So if you know the half wave rectifier operation, then it is easy for you people to understand the full wave rectifier operation. Okay, that is why I have given just a brief structure, so brief diagram or schematic representation of half wave rectifiers and the equivalent waveforms of the half wave rectifiers here. Let me explain the operating principle of half wave rectifiers in brief, because it is not included in your module, but still, so for the better understanding of the operation of the full wave rectifiers, I am including first half wave rectifiers. We'll discuss first half wave rectifiers operation and then we'll go for the full wave rectifier operation. Okay, yeah. Here half wave rectifiers is an electronic device, once again convert AC to DC, but only during one half cycle of AC. It is capable to convert one half cycle of AC to DC here. Okay, you can see here this is an AC signal. Okay, so only one half cycle is converted into DC, other half cycle there is no DC here. Pulsating DC I am talking about, these are the rectifiers, they produces a pulsating DC, then it is fed to regulators to get the constant output DC here. Okay, so that's this is an equivalent circuit diagram and this is the waveforms of the rectifiers. So here we are having a single phase AC supply which is required, which is taken from the supply mains, and then we are having a transformer, okay, which converts or step downs the voltage or step up the voltage based on the requirements. Okay, so the requirements, if it is the higher voltages, then it is steps up, if it is of lower one, that is will step down. Okay, that is based on the requirements your transformer will be operating. Let me take here is, so it is a 230 volts transformer only, 230 volts supply, and it is transformed to around 12 volts only you can take. Okay, 12 volts, 230 volts AC. Here it is 230 volts AC is the primary one. Okay, in the secondary we have, it is 12 volts AC. Okay, So from primary it is 230 volts AC, the secondary of the transformer we have 12 volts DC. Okay, then this is a diode which is used here. So diode we are used here, okay, to rectify the signal here. So what happens when the input is applied? This is your input signal, just observe here. So input is positive here, so this is the positive input, okay. This is the negative sir. AC is nothing but it consisting of positive and negative waveforms, okay, negative portion, okay. So when the input is applied to this from the transformer applied to this diode, okay, so this positive voltage is applied to diode in the first half cycle. That means, so your anode, this is your anode and this is your cathode. So if you take this diode, it's an anode and it's a cathode, okay. So if anode is a positive and cathode is a negative, then operation of the diode, just recall the previous classes. So it is forward biased. Forward biased means it is starts conducting. So if start conducting, the current is flows from source to load here, okay. That is why, so if the anode is positive, cathode is negative, so diode is forward biased and starts conducting and transferring the current from source to load here, okay, and it is repeat, cycle is repeated, okay. So see here, so positive, so it is transferring power, so transferring the voltage, whatever the quantities which is there, it is transferring, so positive will come. See, in the negative half cycle what happens? This is your negative half cycle. This is your negative half cycle. Negative half cycle what happens? So initially it is positive, it is coming at the diode. Now the diode is, anode is receiving a negative polarity. So this is a negative polarity and this is a positive polarity. So if the anode polarity is less than the cathode polarity, then it is the diodes will be acting as the reverse biased mode and it is open circuited, okay. And if the diode is open circuited, there is no flow of current which takes place from source to load. That is why the load voltage is 0 here, okay. That is why, so in the forward conduction mode, diode D1 is acting and transfers the power and it will contribute in transferring the power towards the load, whereas in the second half cycle, the diode itself is in a reverse biased condition and it is not able to transfer the power from input to the load side, okay. That is the difference between the positive and negative half cycle. As it is transferring only half cycle of AC into DC, it is called as half wave rectifier. If both cycle, if the positive cycle as well as negative cycle, if it is converting, then it is called as a full wave rectifier. As it is converting only half cycle, half portion of the full wave, half portion of your signal, input signal, it is transferring, so it is called as half wave rectifier, okay. That's about half wave rectifier operation. I hope you people have recalled the function of half wave rectifiers. Just recall the experiments which you carried out in the analog electronics lab also, for the better understanding of the full wave rectifiers, okay. Yes, next we will go for the full wave rectifiers. So full wave rectifier, here why single phase full wave rectifiers? Okay, we are having a 3-phase rectifiers also full wave. Why single phase? Because in this module single phase rectifiers are included, that's why we are studying it, okay. In the next modules, in third, fourth module, therefore 3-phase rectifiers are there. We will discuss about the operation of the 3-phase rectifiers and all, okay. But why this single phase rectifiers only, okay. Here, to produce the purely DC supply, less ripple voltage or current, less ripple content. Ripple content is nothing but somewhat unwanted portion, okay. There is how to calculate the ripple factor and other things. There are some of the equations where you can calculate the ripple factor of this circuits. Why single phase full wave rectifiers? The question will definitely arises in everyone's mind, why it is required, okay. These are the answers for that questions, okay. To produce a pure DC voltage or a current, pure DC voltage or current, and suitable for high power applications. So half wave rectifiers, single phase half wave rectifiers are not suitable for the high power applications. They are designed for the low power applications, okay. So whereas the single phase full wave rectifiers are suitable for the high voltage applications, okay. So that is why it is used here, used for the high power applications. Next is then average current in the AC source is 0, thus avoiding the problems associated with non-zero averaging source. especially in case of the transformers. So in case of, if you're using the transformer, there are some of the possible problems may happens. So if you're using a single phase rectifiers, there all the problems may be avoided here. That is why the single phase transformer, single phase rectifier, full wave rectifiers are used. The main agenda behind using the single phase full wave rectifiers, they are used for the high power applications, whereas this single phase half wave rectifiers are not used for the high power applications. Okay, that is the main funda behind it. Okay, so here single phase full wave rectifiers, once again there is a question. We have two types of single phase full wave rectifiers: single phase full wave rectifiers with center tapped transformer, then we have a single phase full wave rectifier, bridge rectifier, with a center tapped and bridge rectifier, center tapped transformer and bridge rectifier. Two types of single phase full wave rectifiers we are having. The operation of both we will discuss in detail. Okay, this is the efficiency versus real power of rectifiers, which is a generalized graphical representation of the variation of the efficiency for the variation of the power is indicated here. It's a general, completely of general graph I am shown here. The particular graphs and other things we will discuss it once it comes in your module part. Okay, so that's about why the single phase full wave rectifiers are required. Why only the single phase full wave rectifier? Why not half wave rectifiers? I told already very clearly, half wave rectifiers are used only for low power applications, whereas full wave rectifiers are used for the high power applications. Okay, that is the main difference. Yeah, I told here single phase full wave rectifiers, I told two types in case of single phase full wave rectifiers. Here the figure shown in this particular slide, just a second. Yes, figure shown in this particular slide are yes, the figure shown in this particular are single phase full wave rectifier, that is a center tapped transformers. Okay, single phase full wave rectifiers with a center tapped transformer here in this case. Okay, which is connected to the R load, resistive, purely resistive load. Here there are various types of loads we are using in the system, but in this circuit it is pure resistive load is used. And okay, it is a single phase full wave schematic representation, or we can say it's a equivalent circuit of single phase full wave rectifier, that is a center tapped transformer which is connected to purely resistive load. Okay, that is the equivalent circuit here. You can see here single phase AC source, is there. It's a step down transformer. How to identify which type of transformer it is? Always stepped down transformer is having the primary windings more compared to the secondary windings. So primary windings are more, secondary windings are less. So it's a step down transformer. Okay, so step down transformer. Then we having a diodes, two diodes, D1 and D2. Two diodes are there, and load is purely resistive load. Okay, center tapped transformer. This is a single phase full wave rectifiers with a center tapped transformer connected to purely resistive load. Okay, so here see, I'll just explain the operation here. So both the first half cycle. So here also we apply the sinusoidal waveforms. So in the first half cycle, what happens? So this diode gets the positive, okay, and this diode gets the negative supply at the anode. In the second half cycle, this diode gets the negative and this gets the positive, this diode. Okay, diode D1. So I am indicated here. So the positive half cycle, diode D1 gets the positive polarity and the diode D2 get the negative polarity. In the negative half cycle, the diode D1 gets the negative polarity and the diode D2 gets the positive polarity. Okay, so that is why I indicated here plus or minus both side. Okay, so that is, it is for positive and negative half cycle both. Okay, so in the positive half cycle, I will just explain from here. So in the positive half cycle of AC, okay, so the diode D1, so here it is a positive polarity and it is get the negative polarity. Okay, so the diode D1 is forward biased, as the anode is getting the positive polarity, then the cathode, the diode D1 is forward biased and it starts transferring the current from source to the load side here. So how the current is flowing, it is indicated by the orange color arrow here. So the flow of current in the circuit is indicated when the diode D1 is forward biased and D2 is negative reverse biased. When the positive cycle is applied, so first half cycle the diode is forward, D1 is forward biased, D2 is reverse biased. So in this case the flow of current will be indicated in the orange color. So orange color means the current flows from like this, okay, then here, then to load, okay, then back to the supply here. Okay, this is the flow of current when the diode D1 is acting. Okay, next, when the diode in the negative half cycle means this so negative, this positive half cycle, so diode D1 is acting and the flow of current I shown here. Okay, so in the negative half cycle, it is completed now. So in the, that means, so positive half cycle output waveforms will appear as the current is transferring. So in the negative half cycle, what happens? The diode D2 is forward biased and D1 is reverse biased. It is open circuited. Okay, D2 is acting now. So in the negative half cycle, what happens? The flow of current I'll show you now. So when this D2 is acting, look at the waveforms. Look at the how the flow of current will takes place. So from here, so D2 is forward biased. This is open circuited. The switch is open here. Okay, the flow of current will be indicated here is using the green color. Okay, that the current is flowing like this to the load, then to here, then back to your supply. I think you understood clearly how the current will flows in both the cycle. Okay, so now I'll give you the waveforms. This is positive and negative. So positive half cycle, this positive half cycle, negative half cycle. Here the diode D1 is forward biased in this case. So here diode D2 is forward biased in this case. Okay, so D1, D2, okay, forward bias. So when diode D1 is flowing, so current is in a forward direction. That is why positive output will get. When diode D2 is, it is going in the like this, which I have shown already. There also it will transfers the power. Okay, as both the cycle of AC is converting transferring into DC, it is called as single phase full wave rectifier. Positive half cycle as well as negative half cycles are rectified using the two switches. It is called as single phase full wave rectifier circuit. Okay, that's about the operating principle of your single phase full wave rectifier connected to center trap using a center tapped transformer connected to pure resistive load. The operation is already explained. It is the same equivalent circuit which I have shown here. They have written it in a different manner. Okay, in this case also, the first in the positive half cycle, the diode D1 current flows with when the diode D1 conducts, so this current flows to load. So when the diode D2 current flows through the load. Okay, it is in the same circuit, it is rewritten like this fashion. Okay, just you can compare both the circuit, both are same here. Okay, this is about the operation of single phase center tapped transformer with the center tapped transformer. This is the circuit, this is the same circuit. So this they have written, they are written the load in the middle, that's it. Okay, so this, when this is conducting, it is transferring, this is conducting, it is going like this. The same circuit in the next slide also they have rewritten it in this fashion. So both the circuit remains same, operation also remains same. So first half cycle diode D1 is conducting, second half cycle D2 is conducting. So totally it transfers the power from source to load in both the cases. Okay, that's about the operation printing principle. And the waveforms I already explained it. Okay, this is the positive half cycles, this is negative half cycles. Okay, so in positive half cycle it is diode D1, it is diode D2. So once again D1, D2, like this the cycle will be continue. So this is due to action of diode D1. Okay, this is due to action of diode D2. Similarly, this is due to D1, this is due to D2. So this is how each cycle of AC is converted into DC, and which is appears across the load side. Okay, and this is the input waveforms, AC, pure AC waveforms, and it is a pulsating DC waveforms. Okay, this is how the operation of single phase full wave center tapped rectifiers is working. So another types are there, single phase full wave bridge type of rectifiers. Okay, the operation of that, how exactly it will operates, and what are the waveforms of this bridge rectifiers and other things we will discuss in the next video. So if you got any doubts in this rectifiers, okay, you can feel free to contact me, and definitely will clarify your doubts. Okay, thank you for watching, and yeah, that's it. And remaining single phase, this is over. So in this class, what all the things we discussed is what exactly rectifiers and what are types of rectifiers, what is the rectifiers definitions, okay, rectification, what is a rectification, then we discussed about the rectifier definition, need of rectification, why the rectification is needed, okay, then half-wave rectifiers in brief, okay, so how the function of operating principle of half rectifiers in brief. Then we discussed about single phase, why only single phase full wave rectifiers, okay. Then we discussed in detail operating procedure of center tapped transformer single phase full wave rectifiers connected to R load, and both how diodes are acting. This is also output waveforms of single phase full wave rectifiers, okay. This is how we discussed in this class, okay. In the tomorrow's class we'll discuss about the bridge rectifiers and many more, okay. Thank you.